Now here, what I'd like to do is show you how we can convert from Fahrenheit to Celsius. So the first thing you need to know, Fahrenheit and Celsius are set up to be related in a linear way, meaning the relation between Fahrenheit and Celsius is linear, meaning the Fahrenheit and Celsius conversions appear on a line. And all we need to know, you'll remember from, well, really, you could remember from our profit discussion in week 3, I believe it was. We talked a little about lines, but in general, all you need to know for a line, all you need to know everything you need to know about a line are 2 points. Because with 2 points, you can find the slope and so on. So here I'm going to set up Celsius on the x-axis for convenience. You'll see why in a moment. Fahrenheit on the y-axis. And we know 2 points. We know the boiling point and melting point of water. When, water, which one's melting? Water melts at 32 degrees Fahrenheit, which is also 0 degrees Celsius. So that gives us this point. I shouldn't have drawn it there. Yeah, okay, that's fine. That gives us this point, 0 Celsius, 32 Fahrenheit. Also, we have this other point up here for the boiling point, 100 degrees Celsius, 212 degrees Fahrenheit. And with those 2 points, we can draw a line draw a line going through those 2 points, and the Fahrenheit and Celsius conversions will all appear on these lines. So given a y value, you can find a corresponding x value. Given an x value, you can find a corresponding y value if you have an equation for this line. How do we find an equation for the line? Well, we're going to need the slope. Notice, because I have Celsius on the x-axis, we already have the y-intercept. In a calculus class, the slope-intercept form is not as useful as the point-slope form. But here, we'll just use the slope-intercept form. And to find that, we need the slope. Where do I want to write this? I'll just write it here. Slope equals what? Well, it's a change in y over a change in x. Change in y, 212 and 32. Change in x, 100 minus 0. And what does this equal? Well, it equals 180 divided by 100. That reduces further. Zeros cancel. 18 over 10 equals 9/5. So we have the slope of the line, and now we just need, we can write the equation. I'll say y equals the slope, 9/5 times x plus the y-intercept, which here is 32. And if, y and x, why not? Let's just use F and C. Fahrenheit is on the y, so Fahrenheit temperature is 9/5 of a Celsius temperature plus 32. So if you want a temperature conversion, there's an equation. Let's do a couple examples on the next page. So let's just say example. Convert. Let's make this number work out. Convert, let's see, what's common? Maybe you'll be in Europe or something, and they use Celsius in Europe. And let's say they say, oh, it's 40 degrees here, and you wonder, what does that mean? Convert 4 degrees Celsius to Fahrenheit. That says Fahrenheit. Well, we have Fahrenheit equals 9/5 of Celsius plus 32, which equals 9/5 of 40 plus 32. What's 9/5 of 40? Well, 40 divided by 5 is 8. 9 times 8 is 72. 72 plus 32, 104 degrees Fahrenheit. That F doesn't look right. I don't know how that happened. So that's how we can convert that way. Let's just convert the other way now. So with the other way, you could do a Fahrenheit on the x-axis, Celsius on the y-axis, and get an equation C in terms of F. Or you could solve this F equals 9/5 C plus 32 for C. You'd get C equals 5/9 of all of F minus 32. Or you could just substitute a Fahrenheit in for F and solve for C. And I'll do it like that. So convert. I don't know if this number, maybe I should try to make it work out. Convert. Well, I don't know why you'd ever want to know something in Celsius. Well, convert. Let's see. We want it plus 32 to be a multiple of 9. No, it minus 32 to be a multiple of 9. So that it works out nicely. Now let's make it not work. Now let's make it work out nicely. Why not? Convert 131 Fahrenheit to Celsius. Well, how can we do that? Well, we have F equals 9/5 C plus 32. Let F equal 131 equals 9/5 C plus 32. Subtract 32 from both sides. You get 99 is 9/5 C. Multiply both sides by 5/9. Multiply both sides by 5/9. What's 95 times 5/9? Well, 99 times 5 is what? It's 445 divided by 9 is 91, not 91. 55. I think. Well, yeah, I do know that, but I didn't do it that way. How did I do it? Well, 99 divided by 9 is 11, and then 11 times 5 is 55. So 131 Celsius is, or 131 Fahrenheit is 55 Celsius, using that equation. Let's just go to a new page, so I'll make a remark. Remark. So we have that equation, 9/5 C plus 32 equals Fahrenheit. If we solve that for C, we get the direct conversion. Solve for C to get the direct conversion Fahrenheit to Celsius. And what do we get? Well, you solve for C, you have F minus 32 equals 9/5 of C. So C equals what? We'll multiply both sides by 5/9. C equals 5/9 of F minus 32. And 131 into that would give you 99 as a last example. So, you know, I find Fahrenheit to Celsius conversion, it's definitely something that's useful to know. And it really should be something that they mention in like a high school algebra class when they talk about lines. But I'm not sure if a lot of high school algebra classes make a big deal about how you can get this nice equation just by using the boiling point and melting points of water. So, I would like you to know that.